In this video lecture, I will discuss dynamic cone penetrometer test for soil or aggregate layer. Why do we do this test? Our ultimate target is to measure the resilient modulus of soil or aggregate layer. But this test is so expensive in terms of like time, labor, skillness, and the equipment. So we make some shortcut. In another video, I showed how to find MR using California bearing ratio. In this video lecture, I will say how to find MR using DCP test. What is DCP test? We take a hammer. And the hammer weight is a 8 kilogram hammer. So this is my soil. We place a penetrometer here, cone penetrometer here. Then we drop a load. We drop a load from 18 inch height, a 8 kilogram hammer here. We raise a hammer, drop it on top of this. How much it will penetrate? Yes, for different dropping. So we measure that penetration. So we measure penetration in millimeter per blow. Say we apply 10 blow and it penetrates say 20 millimeter. That means 20 divided by 10. So we take the average penetration. At the beginning, we discard few blows because at the surface there are so many irregularities. After few cycles, we start counting. So hopefully you understood. Very simple concept. There is a hammer. In another video, I will try to make a video. I have that equipment in my laboratory. So we take the hammer, place it and release it, and it drops here. And then this cone penetrate inside the ground, and we measure millimeter per blow. Very quick test. It takes roughly 5 minutes to do it. Then we get millimeter per blow. Then how do we calculate MR? So in your book there is the equation. Let me see. I did not memorize it. It is 255 then 292 DCP 1.1 to 0.61, 1.12 then 0.64. So using this test we get the resilient modulus in PSI. So this value will be in millimeter per blow. So hopefully you understood. Yes, we place a cone on the ground, raise a hammer, drop it on it, and we'll measure the penetration with my blow. Take a average value. If I draw the curve, say this is penetration. This is my blow. At the beginning here, say there, then there. It typically likes this. At the beginning very high, but after sometimes the slope is called millimeter, and this is blow. After sometimes it became stable. We get this stable number and place it here. We'll get the resilient modulus in PSI. So ultimate target is finding resilient modulus. Okay, something else. Also this portion, did I make any mistake? No, yes, everything is right. But just to let you know that this portion is California bearing ratio. 292 DCP 1.12. Yeah, this is in 0 to 100 scale. This is in millimeter per blow. Yeah, in case if you are interested for the relationship between CBR and DCP. Okay, so in next video I will discuss another test.